You're watching FE Exam Prep with Anthony Fasano from Pass the FE Exam. In this video, based on popular demand, we're going to solve another civil engineering related soil sample problem to help you prepare for the FE exam. You can check out the previous soil problem we did on this channel through the link in the description of this video. This Pass the FE Exam video is brought to you by PPI, a leader in engineering exam prep for the FE and PE exams since 1975. PPI provides expert prep courses and study resources designed to help you pass the FE exam the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. With study guides, practice exams, and more, the PPI Learning Hub offers digital practice and review that you can take with you anywhere you have a device so that you can prepare during the times most convenient for you. Check out PPI today at ppi2pass.com to see all the options available for FE exam prep. Let's dive in. This week's problem was created and solved by Enrique Ivers, an engineer in training. Enrique, take it away.
In this soils problem, we're told that a saturated sample has a specific gravity of 2.75 and a total unit mass of 2,500 kilograms per cubic meter. We're asked to determine the dry unit weight and are provided with the following answer choices. A, 2,200 kilograms per cubic meter. B, 2,250 kilograms per cubic meter. C, 2,300 kilograms per cubic meter. And D, 2,350 kilograms per cubic meter. Since we're given the total unit mass in kilograms per 1 cubic meter, and we're asked to determine the dry unit weight in kilograms per 1 cubic meter, we can assume that the total volume of our sample is 1 cubic meter. Since we're trying to find the dry unit mass, we should model the saturated soil as a two-phase system consisting of water and solid. To the right, we can see a diagram of this two-phase system with some of the inherent relationships. Using the FE handbook, we can obtain the following values and relationships. The density of water, rho sub W, is 1,000 kilograms per cubic meter. The volume of the sample, V sub T, is the sum of the parts V sub W for the water and V sub S for the solid. As noted a few moments ago, we're assuming our sample to be 1 cubic meter. The mass of the sample, M sub T, is the sum of the mass of the solid, M sub S, and the mass of the water, M sub W. This sum is 2,500 kilograms. The mass of the solid, M sub S, is equal to the product of the specific gravity, G, the volume of the solids, and the density of water. The mass of the water, M sub W, is the volume of the water times the density of the water. Remember, the total mass is 2,500 kilograms and is equal to the sum of the mass of the water and the mass of the solid. We can substitute in our equivalence relationships for the mass of water and the mass of solids. We can then substitute in our known values, the density of water, and the specific gravity for this soil sample. We're going to move the equation to the top of the screen to allow for some room, and now we can simplify by dividing both sides of the equation by the density of water, 1,000 kilograms per cubic meter. We should also note that the volume of water is equal to the difference of the volume of the sample, which we assume to be 1 meter, and the volume of the solids. So we can use this relationship and substitute the volume of water with the quantity 1 cubic meter less the volume of the solids, V sub S. Simplifying, we have 1.75 times the volume of the solids is equal to 1.5 cubic meters. Further simplifying, the volume of the solids is 6/7 cubic meters. Recall that the mass of the solids is equal to the product of the specific gravity of the sample times the volume of the solids times the density of water. Substituting in our values for specific gravity, volume of the solids, and density of water, we calculate the mass of the solid phase to be 2,357 kilograms. Since our sample size was 1 cubic meter, our dry unit mass is equal to 2,357 kilograms per cubic meter. Referring back to our list of answer choices, we see that the closest choice is selection D, 2,350 kilograms per cubic meter.
I hope you found this week's video helpful. In upcoming videos, we will answer more of your FE exam questions and run through more practice problems. Pass the FE exam will publish videos weekly, so please be sure to click that subscribe button as you'll get expert tips and tricks, including practice problem solutions weekly to ensure that you pass the FE exam. And I encourage you to ask questions in the comments below, and I will read and respond to them in future videos. Maybe there's a specific topic you'd like me to cover, or a question that you need answered. Pass the FE exam will have you covered. I'll see you next week on Pass the FE exam.